welcome to the research seminar series hosted by the Center for Transportation and Logistics at IIM Ahmedabad. It's my great pleasure today to introduce Professor Benny Mentin, who is also a close friend of mine, as the speaker for the day. Our association actually started at University of Waterloo, where I was a PhD student and Benny had just joined the department as a faculty member. Subsequently, I came back to India and joined IIM Ahmedabad as a faculty. And few years later, Benny moved to Luxembourg, where he joined the Center of Luxembourg University, where he joined the Center of Logistics and Supply Chain Management as its director. Benny's research covers diverse aspects of supply chain management, dynamic pricing and revenue management, as well as transportation economics. More recently, he has been working on sustainability in supply chains and harnessing technology to drive digital operations. Benny has published extensively in leading journals, many of the top journals, including Production and Operations Management, Marketing Science, European Journal of Operational Research, Transportation Research, Parts A, B, and E. And Benny is also a board member of the Journal of Air Transport Management, and he is on the advisory board of the European Aviation Conference. So with that brief introduction, I will hand it over to Benny for his research talk today, which is titled The Impact of Market Structure and Scheduling Competition on Prices, Evidence from the Airline Industry. Before Benny begins, just a few words about the protocol that we are going to follow for the seminar today. So I would request all of you to be on mute. If you have any queries in between, feel free to post them on the chat window. I'll try to take up those questions at regular interval, and I'll request Benny to actually respond to those queries. Okay, so over to Benny.
Thank you very much, Sachin. Just a second, I have a little bit of an echo. Thank you very much for inviting me. I'm very pleased to be here. Indeed, we have gone a long way together since we met each other some 13 years ago. We both met in a different continent, different country, and we've both moved and progressed quite a bit since then. For those who don't know, we are co-supervising a number of students, and I'm very pleased to be part of this co-supervision arrangement. I do hope that down the road, when things improve, I will be able to actually come and visit you in person. So when you invited me, I was thinking quite hard what to present. I understand that this is part of the Center of Transportation and Logistics, and by kind of definition, I should have something to present, but I was thinking I need something a little bit more practical, something coming from the industry to demonstrate some evidence of how things operate. While we do quite a bit of that, mainly with industry practitioners, I decided to go back to a project I started a few years ago and put it on the side for a while, and only recently I started looking into it again. It's about how firms compete in different markets. Now, let me start sharing the screen. Okay, just to verify, do you see such in the right mode? It's the, okay.
It's in the right mode.
Thank you. So what we are looking at is how firms compete in the market. Now, let me give you a little bit the motivation. So when you look into different markets, you have a number of competitors. So in transportation and logistics, which is one of the domains, you almost always have some substitution between the agents in the market. If we look in sea shipping, here you have Maersk and MSC. In tracking and other modes of transportation, you have DB Schenker, Kuhn & Nagels. In air freight, I just put two key players that I see, at least here in Luxembourg, almost on a daily basis, Cargolux and Qatar Cargo. And I want to perceive those as two good guys competing with each other, but obviously it's not always the case. Sometimes you have a little bit more of a nuanced type of competition. Now, the way you compete is actually quite interesting, and there is quite a bit of literature on competition in different markets. Why is it important? Because the way you measure competition can have some strong implications. First, there are implications for decision making, for policy decision making. If the policy maker is assessing the situation in a certain market to be not competitive enough, it can impose some restraints on the actors. So for instance, if you feel that one actor is more dominant than others and maybe behaving as a monopoly, you could impose some restrictions on prices, restriction on access to markets, and certain other things that the key player in the market cannot do. Now, when you do measure the competition, you really want to make sure that you measure competition properly. So if you have a good number of competitors, but maybe they interact in the market in a particular way that is not really lending itself to a good degree of rivalry. And I will explain momentarily what I mean by that. But it also has implication for the first decision making, right? So if you are entering a market or you are in the market and you face competition, what do you do? That's certain things that companies often do. They try to differentiate themselves. How do you differentiate yourself? Maybe through different quality, maybe through different operating times, and so forth. And secondly, by entering the market a little bit more aggressively. So if I will take the concept of aviation market, so you can start offering greater frequency in the market. So basically, I will start dominating the different time slots where I can operate more services. Differentiation in aviation could play itself out by what time slots do I post for my flights as opposed to your flights. So if, for example, if you offer a 6 a.m. flight, maybe I should not offer it next to yours, not at 6 and 5 minutes, but maybe I will offer an 8 a.m. flight or an afternoon flight. So the way I position myself in the market against the competitor plays a major role. How do you measure competition? There is an extensive literature in the economics literature about that. The most commonly used is the HHI, the Herfindahl-Hirschman Index. Basically, what the HHI does, it takes the market share of each player in the market. So if you offer 30% of the services and the other one is offering 70% of the services, then you take these two values, the two different market shares, you square them and add them up. This will give you a measure between 0 and 1. It's very easy to compute. If it's closer to 1, it means that the market behaves in a monopolistic fashion. And the smaller the value, it means it's far more competitive. There are different ways of addressing the HHI. For instance, it can be based on number of flights. It can be based on number of passengers that you carry. It can be based on revenue and so forth. So there are different ways to measure the HHI, but generally speaking, they should be more or less consistent. There are other measures that have been proposed in the literature before. I will not get into the details. Generally speaking, all these measures, they have a little bit of a weakness. They don't tell us how firms compete with each other. Now, what do I mean by that? So I told you before that you have different ways of interacting with you. Was there a comment or a... Okay, so the way they compete with each other is quite important. Before I told you that you can start adjusting your schedule, offer a flight a little bit later in the day, and so forth. Now, if you have two competitors, for instance, and both of them offer two flights, let's say. Now, if we will have staggered schedules, so one will offer at 6 a.m. and then I will offer at 10 a.m. and my competitor will offer at 2 p.m. and then I will offer another one at 8 p.m. So we have a staggered schedule throughout the day. That's one way of competing. Another way of competing is that both of us have a flight at 6 a.m. and then both of us have a flight at 2 p.m. Right? That's a very different schedule. That's a very different rivalry between the two firms. And lastly, maybe you will offer the 6 a.m. flight and the 10 a.m. flight, and I will offer the 2 p.m. and the 6 p.m. flight. So those are, again, very different ways of arranging the market. And maybe the last one that I've told you about is actually a market segmentation where we kind of mutually agree that you will take the morning flights and I will take care of the afternoon flights. So basically we have some kind of a collusion in the market. Now, if you think about the HHI that I told you before, HHI will tell you that in all these markets, all this configuration that I've just described, because I offer two flights, you offer two flights, the competition is of the same level. Each of us has a market share of 0.5, 0.5 squared, and plus another 0.5 squared is 0.5. So in all different configuration, HHI tells us it's the same degree of competition. But clearly, you can really realize already that how we compete with each other, how do we coordinate or not coordinating the schedules will have an impact. So schedule-induced competition is quite important, and I will demonstrate with an example. I just pick randomly one market in the US between Charlotte and Memphis. How to read this figure. On the bottom, on the x-axis, you have the different years. So we collected here data from 2009 all the way to 2019. And on the y-axis, you have the daily schedule. So as you can see, if we focus on 2009, there were three competitors in the market, the one in blue, the one in orange, and they were kind of spread out almost equally throughout the day. The first one was offering a flight at 7 a.m., at 12 and a little bit, and at 5 p.m. And the second competitor, YV, which is Mesa, had flights at 11, 1 p.m., 5:30, 8 p.m., and 10:30. What happened between 2009 and 2010? Endeavor, the blue one, decided to exit the market, and Mesa basically took its place. But not all the spots. The one that was offered here at 12:30 was absent. Okay, and then in 2011, three competitors entered the market, the one in red or green and purple. And as you can see, they started reorganizing themselves in a different way. So the first flight was not the 7. So the 7 moved to 7:30. Now it's a 6 and 15 roughly. Now we have a face-to-face competition here, face-to-face competition here. And in the meantime, Endeavor moved, Mesa changed its schedule a little bit. Next year, again, they start reorganizing the schedule one more time. We have another entry. So again, a different schedule. And then at some point, a number of carriers decided, okay, let's leave the market. Only one carrier remained. And you can already see that in this case, when we compare 2014 to 2010, where we had a single carrier operating the market, a monopoly, we have very different configurations. Then one more flight, and change of carrier. It's not exactly change of carrier because this is basically the merger between US and American. So it's basically change of name. But even with the change of name, we see change of schedule and so forth. So the key point here is there is no optimal schedule that we can easily highlight. And every time they compete or change something in the competition, the schedule changes a little bit. So we feel it's critical to capture this degree of rivalry based on their schedules. Here is another quick example. I will not go through the details, but you can easily sense that as you move from 2009 all the way to 2019, the schedule changed all over the place. And clearly, as the schedules and their overlap change, something will happen to the prices. Okay, so what are we proposing? We are proposing to develop a new measure. We call it Schedule Differentiation Metric. It will capture two features. One is how many flights you operate, or how many flights the carriers in the market operate, and how they differ from each other, basically to capture the temporal differentiation between services while accounting for their substitutability. There is quite a bit of literature out there on schedules in aviation, but they don't tell us much about the impact of these schedules on and rivalry on fares. Basically, they demonstrate that as you increase the frequency, you can stimulate demand. What's the impact of an additional flight? In fact, it's not that high as one would assume. It was estimated to be in the range of €3 for leisure passenger or 15 for business passengers. But clearly, there is also a little bit of a trade-off between the frequency and efficiency. You want to offer frequency because it gives you dominance in the market and because it can stimulate demand. But at the same time, having too many flights may force you to switch to smaller aircraft. So you are hurting your efficiency. Okay, so how does it work? I will not go through the math too much, but basically we're looking into rivalry between two carriers. We call them Airline I and Airline J. We assume that Airline I operates N flights and Airline J operates M flights.
Benny, can I interrupt for a minute?
Yes.
So there is a query from one of the participants which says, could you please give an example for temporal differentiation?
In what sense? So the temporal differentiation, that's basically what I described here. So how you can think of how many minutes are apart from these two flights, the competing flights. I will give another more concrete example once I demonstrate the metric. And if it's still not clear by then we can revisit the question.
Okay.
Okay. Basically, I will skip the math here. We do a little bit of ranking and then we develop a matrix. So we look into the ranking of flights with their competitors. We measure the difference in terms of time in minutes between competing flights. And then we look into the measure of difference again. We carry out the matrix manipulation here. We normalize by the number of flights and we get a measure. Now we will demonstrate. So hopefully things will become a little bit easier here. We have two carriers, Airline 1 and 2. They operate 2 flights each, 8, 11, 2 p.m. and 5 p.m. Okay. So the difference between the flights is 100 minutes away between the first and the second flight of the day. Now I want to measure the difference to the second competing flight. So from the perspective of the first flight, the black one, The second competing flight is the one at 5 p.m. The difference to this one is 440 minutes, okay? Now, let's look at the second black flight. There are two competitors, the one at 11 a.m. and the one at 5 p.m. They are equally distant, so it doesn't matter which one we pick. They are 180 minutes apart from each other, okay? So this information that we have right now, we can store it in a matrix. We call it the differentiation matrix, the diff matrix, okay? So the column relates to the first flight of airline 1, and the second column relates to the second flight of airline 1. So the first flight of airline 1 sees a competitor 180 minutes away and another competitor 540 minutes away. Same thing for airline 2, sees a competitor, so the second flight of airline 1. There is a competitor 180 minutes away and another 180 minutes away. If you think about the rows rather than the columns, so this row is the row relating to the first flight of airline 2 and the second flight of airline 2. Is it clear enough? So if you think about the first row, now I will think we are talking about the first line, the first flight of airline 1. So there is a competitor here 180 minutes away, and the other competing flight is again 180 minutes away. So that's the row here. And the second one, again, it relates to the second flight of airline 2, the one at 5 p.m. The competitors are 180 minutes away and 540 minutes away. So that's why we have these two entries. So you can take both perspectives. And both perspectives are relevant because we are going to look at the degree of competition, basically how substitutable are flights. What do I mean by that? So again, when we were thinking about the first flight of airline 1, we see two competitors, one at 11 a.m., which is 180 minutes away, and another one at 5 p.m., which means it is 540 minutes away. So which one is a closer substitute? If somebody wants to take a morning flight, it will probably consider the one at 11 a.m. as a close competitor, will give more weight for this substitution between the two flights. And the one at 5 p.m. will not be such a competing flight because it's not exactly a good substitute. So to that end, we are going to rank the competition. For the nearest flight, we'll give a weight of 1. For the second nearest flight, we'll give a weight of 1/2, and then 1/3, 1/4, 1/5, and so forth. And then, depending on how many flights we actually have, we will reweight them. That's a technical aspect that we have to do in order to make sure that the weight sum up to 1. Okay, let's go with the columns first. So that's rank M. So the rank N is the ranking of the flights according to airline 1. So I'm looking at the columns. That's the perspective of airline 1. And airline 1 sees a competitor at 180 minutes away, give it a weight of 1. Another one 540 minutes away, give it a weight of 1/2. So the total of the two weights is 1.5. So I'm now rescaling. So I had 1 here over 1.5 gives me 2/3, and 1/2 over 1.5 gives me 1/3. Same thing here. Here it's actually quite arbitrary if we pick this one first or this one first because they are symmetric. So that's how I'm getting the rank N for airline 1. I will do the same for airline 2, but instead of looking at columns, I will do the same on rows. So hopefully I can speed up a little bit. So rank M, now sum up, you can see it sums up to 1 when we sum along the row. Now we have 2/3, 1/3, and for the second flight, 1/3 and 2/3. Okay. What I will do next, I will multiply them. So I take the rank of n, the differentiation matrix, and the rank of m, multiply them all. I get this metric. I sum up the entries in this matrix and normalize. I'm normalizing by the product of the number of flights offered by each. I'm getting 217 minutes. How to think about the SDM? So the value of 270 minutes can be perceived as the weighted average of time between competing flights, kind of normalized to the degree if they were offering one flight each. Okay, so if I were to remove all the number of flights in the market and keep only 2 flights, one by each, then they would be 217 minutes away from each other. Does it clarify the question we had before?
So Prince, if that does answer your question, you can let us know. Otherwise, we can proceed ahead.
So that's what we get for 2 flights spread out during the day. Now, we have some properties that we derived. I will not bother you with the details of the properties, but I will just demonstrate a little bit with a number of examples. It will be a little bit easier to grasp it. So the first example is the one I've described in detail. Now, what we do from the first to the second example, as you can see, the black flight at 2 p.m. is moving to the right. As you can see, the measure gives the same value exactly. Why is that? Because as I bring the black flight closer to the white, they become closer substitute. But at the same time, it becomes a weaker substitute of the one flight at 11 a.m. So this is basically some kind of an internal substitution. You can move to the left or to the right, nothing really happens. So you remain at 270. But once the flight goes from this internal range between 11 and 5 p.m., once it jumps over to 5 p.m. plus some minutes, or over from 11 a.m. minus few minutes, then you are in a different regime. It's a different type of rivalry. And as you can see, they start moving away from each other. So as this black one moves to the right, it becomes weaker substitute of the 5 p.m. and also a weaker substitute of the 11 a.m., which means that the degree of SDM goes up. Now, going back to the original example here, switching it with 4. So as you can see, the 11 and 2 p.m. switch position. Okay, what happened here? Basically, the 2 carriers agreed to split the market. You take the morning sessions, I will take the afternoon slots. Basically meaning that we are some kind of weaker substitutes. So that's why the number 1 example is of a greater degree of rivalry than the example in 4. And that's why we get a higher value of SDM. Then I can bring the flights closer to each other. Here they are perfect substitute, but there is still some distance here. We can see that the degree goes down. I move them a little bit closer to each other, the degree goes further down. And if I take the example from before, from 5, I remove 1 flight from each slot. And this is basically the measure of 360. And lastly, when the 2 coincide completely in a single time slot, the measure is 0. So that's the perfect competition. That's the most severe type of rivalry. So you can see the range of values that we obtain here. And what we do, we then go into some data collection. This is what we have done a while ago. We decided to focus first on duopoly markets, where we have primarily 2 carriers competing with each other. We have a mechanism to eliminate markets that do not obey, basically, because in the US, when you look at markets, you normally have in duopoly markets 2 key competitors, but you have a lot of noise. You have many small players that operate occasional flights and so forth. So we want to focus on consistent competition. So we keep if we have two major carriers, such that they count for at least 80% of the flights. We look into 3 years of data, 13, 14, and 15. We use data from the Department of Transportation on schedules to derive the SDM. We measure the HHI as well to demonstrate that HHI provides value, but SDM can provide some additional information on the degree of rivalry. We measure whether a carrier is a low-cost carrier or not. And that's quite important here because if there are two types of carriers for those who are less familiar. So there are network carriers and low-cost carriers. Low-cost carriers have a very different operational mode than network carriers. So network carriers will have different fare classes, will have a variety of aircraft types, will serve a wider degree of markets, and normally will also operate according to a hub and spoke type of network. LCC have a very different mode where they simply try to operate a single aircraft type and focus on certain type of markets. So that's why we want to measure their presence a little bit differently. We want to capture information about the markets in terms of population, income, and we use instruments following the literature, so I will not get into that. So that's a standard way of looking into things. Now, based on the data, this is what we observe. First, an overview on the SDM. So SDM, when we look into the different markets that we have in the data, on average, SDM is about 300. So in most markets, airlines organize themselves such that they are about 300 minutes away. So that's about 5 hours. But there is quite a distribution. So in some markets, they differentiate themselves quite dramatically. And basically, when you move to the right, essentially, you are looking into markets where they completely separate them from each other. One operates at the very beginning of the day and the other one at the very end of the day. And you also have some markets where SDM is extremely low. This is when those two firms, two airlines, basically have almost converging schedules and they fight over exactly the same time slot. Now, what I want to demonstrate next is the impact of frequency to SDM. One might argue that, well, SDM is quite a factor, is quite impacted by frequency. Because the more flights you operate in the market, it changes what you could do. And that's exactly what we see, but with a little bit of a twist.
Benny, can we take up a question now?
Sure, yes.
So there is a question from Ganesh. The question is, can you throw some light on the impact of any FAA regulations on scheduling on the rivalry SDM values? Also on the impact of differential airport charges during rush hours on rivalry / SDM. Is the question clear?
Sorry, the first question was regulation, right?
Right.
Very good point. I'm not familiar with any regulation at the moment restricting flights, at least not in this context. So the context that we are looking at is US market. And in US market, basically the operational mode is first come, first serve. There is quite a bit of lobby work involved, but because of that, they cannot impose any restrictions. It may raise some other issues, whether it's efficient or not, but that's a different discussion. What may happen often in the US, especially in major airports, that you have a congestion in the morning. Everyone wants to offer the 6 a.m. flight. So you have like 8 carriers all operating the same time slot. Clearly, it's infeasible, but that's why you have a certain degree of congestion in the morning. So they cannot really they try to send signals to each other in different ways, but probably it's not the most efficient. Having that said, there are 4 airports that are a little bit different and they do have constraints. There are 3 or 4 airports in the US, I don't remember their identity right now, that are slot controlled, the way that most airports in the way are slot controlled. So slot control means that they don't operate according to the first come, first serve, but they have a mechanism to allocate the slots in advance. We do capture those airports differently in the data here. So basically we have a indicator whether this airport is slot controlled or not, because clearly it does affect the measures. And the second question was on times, peak times and so forth. We decided it's very hard to capture. Now it's a question, what is a peak time? There is a peak time at the airport, I agree. So if you are going to your business travel, maybe you want to take the first flight of the day so that you can come back in the evening. But once you are looking at the continent level and looking at all the different markets, it becomes quite a challenging endeavor to decide what would be a peak time to fly. So if you're looking, let's say, East Coast, East-West type of flights, is flying at 6 a.m. better than flying at noontime? And as you look at the other way around, is flying in the morning is different than flying at night? And then we decided, okay, for instance, when you fly from San Francisco back to New York, you have the option of taking the red eye. Some prefer the red eye, but some would rather stay away from the red eye type of flight. And we thought, okay, becoming kind of subjective rather than objective, and we would rather not put it in the data as a measure. But I think it's a great question, but something that is really hard to quantify because each market is different.
I hope that answers Ganesh's question, so we can proceed ahead.
So going back to the frequency, there is an interesting observation here. So when you have only 2 flights in the day, so one from each competitor, the range of SDM value you get is basically all over the place. They can either be at the very bottom here, closer to 0, so there are the two flights compete fiercely with each other, or they can be completely separated at the 2 ends of the day. Clearly, the more flights you enter, kind of diminish or start to restrict what you could do. Because if we start operating 20 flights and there are 2 of us, so let's say 10 each, normally what you would do is basically have a staggered schedule. Not necessarily, but most likely in many cases it's a staggered schedule. Whether they compete fiercely with each other or not, it's not very clear, but just the fact that you have 10 flights each throughout the day kind of restricts quite a bit the range of SDM that you can offer. So that's something that we should take into account. And the second is to demonstrate here on the right-hand side, we have the SDM against HHI. Since we are dealing with duopoly markets, you can see the almost horizontal line along the 0.5, right? So when HHI is about 0.5, you see a very clear horizontal line, meaning that in many markets, the 2 carriers basically offer the same number of flights. Even so, even though they do that, you can see the large degree of SDM values that we get. So SDM, again, can go all the way from 0 up to about 1,000. So even though the standard measure of competition will tell us, well, all these markets are the same, we can come and say, no, they're not exactly the same. There is another way to measure competition, telling us how they compete, how do they organize themselves in the market to differentiate or not in terms of their product offering. And clearly for any HHI values that you can take, you can see a range of SDM values. And that's why we believe that coming up and using such a measure can give policymakers and decision makers from industry another tool to think about the process of competition. So then we proceed with the standard measure of running an empirical analysis. I will not go into details, but ultimately we want to assess the impact of SDM on fares.
Benny, can we take one more question very quickly? So there is a question from Pallavi Joshi. The question is, what I understand is, what is the role of travel management companies in relation to schedule?
Role of
travel management companies. So Pallavi, would you like to unmute yourself and clarify the question, because it's not completely clear to me either what exactly the question is. Okay, is the question clear to you, Benny? The question is how or what is the role of travel management companies in relation to the schedule?
Yeah, if I assume that those are travel agencies, then they might engage in the negotiations between companies in the market, but it's not something we can capture here. I guess the point is, what if you buy a package, right? If you buy a package that will include a flight, so say you want to go to Florida to Orlando, and then you have it in the package, it's not very clear. So the only data when you go into the DOT, all you can see is what passengers actually paid for the flight. So when they buy a package, the travel agency will have to disclose what is the component of the flight. So I don't see the rest. I only see the fare part of the package. And this is the one that is reported in the DOT. So that's why it's a little bit up to the travel agency and the airline to discuss the fare. If I got the question right. If not, just let us know and we can follow up on it again. So our objective is to identify the impact of the rivalry between the two competing carriers on the fare that passengers pay. The way we do it is we have the standard method of running regressions. What we do need to capture as well here is IV. So IV is like instrumental variables, and the notion is that when you have measures like HHI and SDM, one might argue that they are determined endogenously by other factors in the market. So you might say, well, look, the capacity, the potential demand in the market already determines how many competitors enter the market and how they compete with each other. So we run the proper estimates to make sure that we capture it properly. So all in all, we have just under 1,000 markets. We identify in general 14 carriers that enter the different rivalries. And here are the regressions. Again, I will not bother you with the fine details, but we run FE means fixed effects because we want to capture the identities of the different markets. We have fixed effects with IV, so IVFE. So one that captures only HHI and one that only SDM, and the last one that is including both. So if you look at the IV, clearly HHI is important. We knew it from before. So as what this number means, 1.7, I will skip the magnitude by just the directional effect. So as HHI goes up, meaning the market becomes more monopolistic in terms of the market share captured by the two carriers, the price goes up. Okay. If you look at the SDM, as carriers separate themselves from each other, the price goes up. Then the challenge is if I throw both measures into the same regression, and this is IVFE3, we see both are still positive. Clearly, the magnitude changes a little bit, but that's not really critical at this stage. But we see that HHI is positive, SDM is positive, and what you can see here, the two stars, it means that it's positive at a very high probability. So we say like with a confidence of 0.01, so 1%. So we are highly confident that this is the right estimate, and it means that both should guide the decision makers in terms of determining not only the degree of competition, but also the degree of rivalry between the competing carriers. Okay, so that's basically the key message of this paper. We have a number of other regressions that we carried out to measure the robustness and so forth. We also normalize for the market capacity, but basically the different regressions give us more or less similar results.
Yes. Sorry, Benny, can we take a quick question? Yeah. There is a question from Prince. The question is, why do you choose to do fixed effect model? What about random effect model in this pattern data analysis?
So the reason we have fixed effects is because we have the same markets over and over, and so you have the same market for 3 years. So for example, from JFK to San Francisco. And I think we did test the difference between fixed effects and random effects, and fixed effects is the right model. So unless you have a shock affecting the market on a regular basis, the right approach here is to take the fixed effects. And unless I'm missing something in the comment.
I hope Prince is satisfied with the response, so let us go ahead.
Thank you for the question. The last thing
Benny, can we, there's one more question if we can take it up. So there is a question from Pallavi Joshi. Rivalry equation will affect in pandemic scenario, and that's where the travel management companies, their commitments affect airline scheduling.
No, it's a very good point, but we are not. That's why we stepped away from pandemic, and also we took on purpose a number of years that are sufficiently away from the previous crisis, the financial crisis of 2008. So that's why we didn't start earlier. We said like, okay, 3-4 years after the crisis is probably safe enough. 13 to 15 were some of the best years of the industry. I'm not able to say anything about the effect of the pandemic and other disruptions on the commitment. It's a very good point, but I don't have the data to support anything valuable. So what we did beyond is to look not only at the fare as such, but the distribution of fares. So we were kind of curious whether the impact that we see is kind of uniform across the different fare percentiles. And when we say fare percentiles, you might think that the higher fare percentiles, the really high fares are basically paid by business travelers, and the low fare percentiles are paid by the very price sensitive consumers. So we run this set of regressions. And quite interestingly, when we look both at HHI, the top curve, and SDM, the bottom curve, along the different percentiles in the distribution. So we took increments of 5, 10, all the way to 95 percentile, plus the lowest and the highest percentiles of 1 and 99. And what we see that for most of the range, almost from 10% to 90-something percent, SDM is a critical factor in explaining the differentiation in prices. or the differentiation, how differentiation between the schedules affects prices. HHI can do so, but not to the same degree. Now, taking that, we also wanted to further refine the market structure. Basically, what do I mean by market structure? Which carriers compete in the market? So if you remember, we were focusing on duopoly markets, two core carriers, and we were thinking, is the competition between two low-cost carriers the same as competition between two network carriers, and which in turn would be different than one network carrier is competing with a low-cost carrier. We'll take you very quickly through the graphs. So those are the results. As you can see, the important graph is the one on the top right. So on the top right, you have both network carriers. Bottom right, you have both carriers are low-cost carriers, and the one on the left is one network carrier versus one low-cost carrier. And when we look at the degree of competition, when we are looking at the percentiles, our model, our measure is most informative when we have a competition between two network carriers. So what we suspect is that once we have a low-cost carrier in the market, the rivalry between the carriers changes quite a bit. So what is happening? We look into the data a little bit more closely. If you have a low-cost carrier, they almost never compete with another low-cost carrier. So I know we have a graph here of both low-cost carriers, but in fact, the number of observations that we have here is extremely low. And when you have very low number of observations, that's why you don't have any significance throughout. So in a way, we can almost ignore the bottom right graph. So the important graphs are the two top ones. Once you have a low-cost carrier and a network carrier, we see, and this goes back to one of the questions that was raised before, almost some kind of a segmentation of the market. So low-cost carrier try to really move away from the network carrier. So the network carrier will try to offer attractive flights to business travelers, so the 6 a.m., 8 a.m., whereas the low-cost carriers will offer dead time zones, right? So when the airport is almost the least busy, so 3 p.m. or 2 p.m., when there is almost no competition from any other carrier, that's when they get a better deal from the airport, possibly. So this could explain that to some degree. Good, so that's conclude my slides, my presentation. I've demonstrated to you a thinking process about the measurement of competition. The traditional measures do give us important information about what's happening in the market, but they don't capture everything. What they are missing quite clearly is the way firms in the market compete with each other. And to that end, we developed this SDM measure. And as I've demonstrated, it does provide some important information for decision makers, both policy and practitioners. It can serve as a tool, for instance, when you are assessing merger and acquisitions, and can serve as a tool for companies when to slot their activity throughout the day. I want to make a quick comment. We have an ongoing work. What I've demonstrated was for 3 years. What we're doing, we're expanding to a panel of 10 years. So these were the figures I've shown you at the very early stage of the presentation. We are expanding from duopoly to any market. So it can be a monopoly or a competition between 5 carriers. And we are also considering alternatives to the SDM. Maybe we can come up with something that is quite simple and will still capture what's happening in the market. Kind of just on time. I know I took a little bit longer than expected, but I would really like to thank you for your attention and very good questions that you have raised so far.
That was right on time. I think we had targeted for 1 hour. You're right on time. So thank you, Benny, for such a wonderful talk. I think it answered a very fundamental question as to how to measure competition in the market.